whatever, I suppose. Alright. That was epic. Okay, folks. I'm hoping you can hear me, see me, all that kind of thing. We've just had rather epic networking dilemma here. As you can probably see, we're in a new area. This is my kind of new electronics lab, and this is my first time streaming from here, and I haven't gotten the Ethernet cable rigged up here yet. So rather foolishly, I decided, number one, I thought, oh well, I'll just use one of those Wi-Fi power line, connector type things, and that didn't work. I suppose it's not very surprising considering the amount of stuff that's going on here. Number two, then I thought, oh, okay, well, I'll just use my phone because I'm supposed to have 4G. Well, yeah, that didn't quite work out either. So last option on the list for tonight was to go running around like a crazy person. And are you absolutely kidding me? Like, how hard can it be to stream a bit of video? So yeah, I've now got a Ethernet cable running all the way from the laptop up the yard and into my house where it's connected to the router, but it seems that still isn't enough to give us reasonably solid streaming. So I don't know, guys, if anyone can hear me or see me or what. According to this here on the laptop, my video output is too low. But anyway, this is about the best I can do. I'm wired to the router from the laptop, so this is kind of what we're going to get. So I hope you guys can see what we've got rigged up on the bench here. I had been hoping that I'd be able to give you a demonstration of this on the live stream tonight. But if it's going to look like something out of a 1980s arcade game, there's probably not going to be much point in my even trying that. So I don't know, how's the... Okay. Alright. So if you're hearing and seeing me, I'm going to take that as being a good thing. So on the bench here we have a Gen 2 Toyota Prius inverter converter. And let me just go ahead and crank on some of this kit here while I'm talking to you guys. I've been doing quite a few experiments with it over the past day or two, and today reached a bit of a milestone in that I was actually able to charge a battery directly from the mains with this thing. Now, you might ask yourself, well, what's the point in doing all this? But as I said in a previous video, for the 1,000 euro E36 build, I was hoping to revisit the possibility of building a high power charger. Are you guys really getting 1 frame per second? This is ridiculous. This is just crazy. I'm supposed to have fiber internet here. This is just ridiculous. Let me just see if I can change any of the video settings here. I'm on HD. I might try taking that down a bit. It might make it a little bit less stressful on this piece of junk. Try this now. Alright, so I've taken the video quality down. Don't know if that's going to help us, or the video size down as well. I don't know what that's going to do. According to YouTube here, my video output is still too low. So I don't think we're going to have much fun with the stop motion video. Alright, so it looks like it'll be a live audio stream tonight. So how are you guys doing? Anyway, don't mind me and my internet problems. Hope you're all doing well. I don't know, I've tried taking all this down. I'm doing 30 frames per second according to the encoding. I don't know, there's just... So they're turning down the video settings. I am turning down the video settings. I don't know, is this any better? Frame rate 24, I don't know. Video format. If I take it down much smaller, it's going to start getting into 1980s territory. Okay, there's some 1980s territory. I mean, surely now this should be working, Charlie. In terms of there's that question again about the legal stuff. I would ask that you have a look at my first live stream. I covered all that. I covered all that during the first live stream. Oh my god, that is ridiculously low quality. Yeah, this is going to be an audio live stream. Okay, I'm waving my hand in front of the inverter now. Okay, I've just stopped. So what are we going to do? Wait 30 seconds for this? Oh man, this is silly. There's just something stupid going on here. Oh, there's my hand now. Wow. Yeah, this is pretty seriously lagging, isn't it? Alright. But this is a bit of a pain in the neck. Okay, so frame rate is getting better. Okay, I'll try going up one more. I'll try going up one more. Where am I going here? Video capture. So I'm at 640 by 360. I'll try 800 by 448. Wow. Let me take the frame rate down. I'll try like maybe about 20 frames per second. That might be enough to make it work for us. Yeah, I don't know, guys. Well, this is one botched up live stream, that's for sure. Would I consider doing conversions full time on a commission basis? If I can get decent internet, possibly. I don't know, guys. I get that. I get asked that a lot. What do you think? Should I? Your call. I don't know. There's probably about 99% of people that think they want to do a conversion actually really don't. I know that sounds cynical, but it's kind of the sad fact that it's just a sad fact that I've kind of seen, but who knows, maybe that's going to change now. Well, thanks for the votes, guys. I'll try giving you another wave here now. In fact, you know what I'm going to do? I'm going to just jump off here. I'm going to shut down the encoder just for a minute here and just try changing something. I will be right back in a minute or two, so don't go away and don't touch that dial. We're back. We're green. Yeah, that's a fact, Tom. Half of this is going to be me, you know, having a bit of a nightmare with the old connectivity. Is it resuming? I don't know. The spinny thing never inspires me with much confidence when I see the spinny thing. Well, at least you guys got some cool pictures of the lab tonight. I have a feeling I'm going to be making a video on how this thing works rather than trying to live stream it. Alright, good. Okay, so are we now working? I'll try waving this time. Alright. So, anyway, yes, I have shoes on today. Alright, sweet. Okay, brilliant. I did wave. I'll wave again for you. Alright, okay, sweet. We are working. I'm going to put my feet up on the desk here so that I can, you know, look cool and not slide off the chair. Oh God, I'm sliding back. Here we go. All right. Now, okay, as I was saying, show us the feckin' thing. Okay, right. So, on the bench beside my foot, we have a Gen 2 Toyota Prius inverter converter. Now, what some of you may or may not know, and I know some people do know, is that inside this thing there are a number of rather interesting devices. So I'm going to be able to see me now. Hello. Right. In here, in the back, is a dual three-phase inverter. And up here near the front is a buck boost converter capable of about 20 kilowatts. Now, you might say to yourself, well, you know, what good is this in terms of us being able to, you know, charge batteries or do things that we need to do for conversion projects? Well, I'm kind of hoping that if it doesn't blow up, I'll be able to show you. So, see these two big crocodile clips here on the back with the bolt sticking up. In there we have a mains cable. I can find the other end of it for you here. We've got a 13 amp plug on it. So this is basically a torture device. I've got a mains plug and I've got croc clips. So you could theoretically torture somebody with this thing. Now, the two bolts that you see, in fact, why don't I give you a close-up, seeing as we have high quality video streaming functioning now. Here we go. We're going in. So the two bolts that you see here are sticking out of two of the three-phase terminals of the MG1 motor connector. And for some of you that don't know what that is, I'll try to show you out here. Go into the main part of the shed there, and I don't strain a cable. You'll see a Toyota Prius Gen 2 trans axle sitting on the engine stand. And you see that orange cable sticking up the top of it. That is one of the motor three-phase connectors. So on our inverter converter, MG1 connects here at the back, and MG2 would connect here. And this part here is the inverter, and this stuff here is the converter. Now the converter is the bit that we're playing with, because this half bridge IPM module and this inductor form one hell of a powerful buck boost converter. Now, we are feeding a PWM signal into the CPWM lead of the buck boost IPM, and at the minute I have a little circuit here on a prototype board that is taking a TTL square wave from an analog discovery that's in the back and converting that up to a 12 volt CMOS signal that is needed to feed our buck boost module. And you'll see on the oscilloscope screen there that we've got about a 20-25% PWM duty. Now, down here on the floor, you will see we have a Toyota Prius battery. Yes, I've got a few of these things now. And to the right of it, I have a car battery, just a normal 12 volt lead acid battery here that I'm just using to pull in the contactors and the pre-charge relay in our Prius battery. Now, Prius battery is connected to this terminal block here and goes into where the normal DC cables for the Prius battery connect. Now, let's get you folks set up in a place where you can see the fireworks. I'll try not to trip over all of these crazy cables that I have here. So I'm going to have to do a bit of more video madness now, and we'll oh, it is sketchy. There's no doubt about it. This is sketch city. The Prius battery is about 1.3 kilowatt hours, of which in the car they allow you about half of that. We have no such concerns about that kind of thing here though. We'll just pretty much max out. So now, oh yeah, I also didn't show you that I have a big 3 kVA variac here. Now, let me get a look and see what the video looks like so I can see what you guys can see. Well, the great news is I have no feedback on the computer here, but I'm going to jump into the encoding software. And, oh yeah, okay, so you can see it all. All right, sweet. Now, let me just bring you guys up a little bit so you might be able to see the multimeter screen here. All right, maybe because the light will probably wash it out too much. But this meter up here is going to display the DC bus voltage. This meter here is going to display what will ultimately be the battery voltage. Now, time to get sketchy, because the analog discovery here should be feeding our waveform in. I'm going to change this to about 29%. So that is now, oh, and of course the scope's gone to sleep. Whee! Okay, now I've been doing some experiments because what tends to happen is that wherever you have voltage applied, be it on the battery or on the inverter DC link side, you seem to get conversion no matter what PWM that you put into the thing, and it can get seriously scary depending on what's going to happen next. So, oh yes, and by the way, for you safety Nazis out there, the case of the inverter is connected to mains earth, so try not to worry too much. Right, okay. Job number one is going to be to plug in the variac, so I'm going to do that. Oh, here we go. Okay. Oh, my inverter. Oh, it's gone dark. I wondered why my solar inverter wasn't doing anything. All right. Okay, variac is now hot. We're now going to grab the cable with the torture device cable. Okay, so the torture device plug is connected to 2 of the 3 MG1 phases, and also earth is connected to chassis. Now, we are now plugged into the variac. The variac is powered up. So my next job is now going to be to pre-charge the battery side. So you should see, I don't know if you'll be able to see it, but I'll call out the readings to you. The minute that it gets battery voltage coming in, it's going to start boosting it onto the DC link. So you'll see a voltage on the benchtop meter up here, and you'll see a voltage of the actual battery on the small portable DMM here. So, all right, we want to connect not the main contactor, we want to connect the pre-charge. So pre-charge now. And, oh yeah, because I don't have the, well, that was a bit anticlimactic. I didn't have the service disconnect in. So, okay, let's put in the service disconnect. By the way, guys, I have been absolutely maxing out on the Weber Auto YouTube channel. I can highly recommend it, but I somehow don't think that Professor Kelly would be too impressed with my particular setup here. Now, okay, so we are going to pre-charge now. Okay. Right, so we have 198 volts on the battery, and we're currently boosting that to 275 volts. So, this is where the fun starts, because what you're going to see now is the battery voltage is dropping, and you can see we're at 194 on the battery now because it's in a fairly discharged state. And also the voltage on the DC link is going to be dropping as well. I'm now going to close the main contactor. Main contactor is now closed, so the system's hot and we can definitely get fireworks. So now activating the variac, and we're going to start pumping 50 Hertz AC in through the powered up but disabled MG1 inverter. So I'm now winding up the variac. Oh, and I forgot the clamp meter for the DC current. You muppet, Damien, you can't be forgetting these things. Now let's clamp that on here. We can see what kind of DC current we end up getting. Hopefully not too much, because too much is bad. Now, all right, here we go. Winding the variac up now. Now, once we reach a voltage on the DC link that exceeds voltage that we have there, here we go. Okay, we're now pushing current. I'm going to wind the variac up to full. Okay, the variac's now full, so we're applying mains current to MG1. As you can see, the DC link is at 306 volts. The battery is at 2118. We're pushing 2.5 amps into the battery. I don't know if you can see the oscilloscope, but we've got a bit of spikiness on the waveform, which, considering the mess of wiring that I have here, is not a surprise, but it doesn't seem to be affecting things. Now, I got a question for you guys, seeing as it's me that's risking life and limb here. And that question is, what is the switching frequency of the Prius converter? Because I'm running at 8 kilohertz at the minute, and I'm not 100% sure that it's the right frequency. But hell, I mean, what can possibly go wrong? So what do we do when we have something working well? More power. So we're at 29% PWM now. I'm going to kick it to 28. We're now pushing 2.4 amps to 22. Let's go to 27% PWM. 3 amps going into the battery and 223 volts DC, 305 on the DC link. 26%. Oh yeah, and I've no cooling on this, so things could go bad quickly. So okay guys, come on, talk to me geese. Someone needs to tell me what the correct switching frequency for this thing is. Now at 3.1 amps on the battery, 224 volts. There's 304 on the DC link. Who wants to see more power before this thing melts down? 25%. 3.7 amps DC at 225 and 302 on the DC link. So, okay. Point of all this madness is that with the addition of probably a little Arduino, like an Arduino, you know, at Mega 328 or something like that, and you know, like a 70-cent MC1405 or something like that. It's just a TTL to CMOS converter chip. You too can be charging your battery with a Toyota Prius inverter converter that you can get on eBay for about €100. So 2 to 25. Oh really, Tom? 20%? 2 to 25 is listed for CPWM. That's interesting. I wonder, does it change the switching frequency, you clever Japanese people? I wonder, do they change the switching frequency depending on certain conditions? 24%? Who's for 24%? Give me a vote here, please. Okay, 24%. Expects 0 to 10 volt PWM. Nominal switching frequency 2 kilohertz. And I'm pushing 8 kilohertz through it. That might be annoying it. Okay, I'm gonna back things off. All right, okay, let's go for 24, and then I'm gonna shut it down and stick my finger into it and see. The 24 is now giving me 3.1 amps at 228 on the battery and 301 on the DC link. I'm gonna go back to 29 now, which should pretty much shut us down. Yeah. That pretty much kills us. I'm going to wind off the AC. That is off. And I'm going to kill the battery power. And we let the capacitors discharge. And then I'm going to stick my finger in here. And yes, I'm going to wait until all the capacitors discharge, which they have just done. Now, so sticking the finger in. The top of the IPM is a little bit warm. The inductor is stone cold, and if I can get my finger in past all those pesky high voltage connections there, the heatsink is stone cold, and there's no coolant going through this thing. So, Oh, you know, I'm not gonna die, guys. With the AC current, I would have been able to read if my wonderful AC power meter hadn't decided to go asleep. I mean, I understand things need auto power off because people forget to power them off. But how about give me the choice to have it? You know, whether I need auto power off or not. Anyway, um, point is, guys, uh, you can pretty much use one of these things to make a battery charger, and that's, you know, kind of what I'm gonna do with this one. It might also be something that I might consider doing would be to strip the converter out of there and put it on an air-cooled heatsink. Then it wouldn't need liquid cooling. Could also, if we wanted to be completely mental, put two of them back to back, and you would have the ability then to up convert and down convert from both sides. So you could have, you know, battery A, battery A could be a higher or a lower voltage than battery B, and battery B could be a higher or a lower voltage than battery A, and you could pretty much swap power between them. So I've got a few of these Gen 2 inverter converters here, so we'll probably try that. I've also got a Gen 3 one from a Prius. I've got a Toyota Auris one, and I picked up a Lexus, I think an IS 300 one this week for pretty cheap. So, and the hold button to hold the LCD on, I don't think it does. I've tried a lot of these tricks, but I just the people that have written the software for them have obviously decided that they know better what I need to do than what I need to do. So this is kind of a first demo, guys, of the Prius inverter converter. I am wearing socks, yeah. It's probably a good idea to be wearing socks considering the kind of voltages that are flying around here tonight. So that was the big demo. In other exciting news as well. Oh, I better remember to plug out the Variac. In other exciting news, we have gotten the Hubner inverter driving a BMW i3 motor. That's reading the resolver and is generating quite a bit of torque with that. So Gen 2 was 2004 to 2009. Yeah, I never finished the Lexus thing because at the time I was working on that, there were a couple of things went rather drastically wrong in my life, and Johannes also, I don't think was that interested in working with the permanent magnet stuff, but he has now, gotten all that stuff working very well and has came up with this ridiculously simple resolver interface that I have to say does seem to be actually working here. Anyone want to see the i3 motor spinning? It wouldn't be too difficult to get that to work, I think. I saved the parameters in it, so you just have to put power to it in theory. But hey, I'll go through the wiring. I will do a normal video on this. I don't know if I'll get a chance this week, but I'll do a normal video episode on this thing, and I'll show people what the wiring connections are. I mean, one of the things about all this, you know, Prius stuff is that there's quite a bit of there's quite a few projects out there, but as usual, none of it's really that open source, and you know, it kind of all seems to it just all seems to fade away. Nothing ever happens. But as you guys know, and I secretly told you in one of the previous live streams, we're going to be making a car move with one of these Prius trans axles, and we've a project coming up for that. Yeah, well, we'll be getting this inverter working, Gary, in more ways than one. I would like to think that it could be used as a kind of a nearly an all-in-one power module for a DC conversion project, certainly. The problem with the Gen 2 inverters is they're not particularly powerful. So you wouldn't really be able to use one for a road-going vehicle. That being said, some of the Lexus ones are a lot more powerful, and we can potentially make that work also. I have a Lexus one on the shelf there, so I need to start looking at that. But this is kind of where I'm going with a couple of projects now. So, all right, I'm going to see. Oh, I'm going to drop the microphone. Hope no one got their ears blasted by that. Might as well see. I'm not sure now if I can do this because I've got a lot of stuff on the bench at the minute. But if I could steal this guy here. All right, I'm going to power down the. Okay, that's pulled. I'm going to power down this guy. I'm going to power this guy down, and I'm going to rob this power supply so that we can supply DC to the supply 12 volts, I should say, to the inverter here. I'm going to try and show you guys the the i3 motor spinning. Might as well give you something to look at. I need 12 volts and we need forward. I don't know if I saved the parameters in the last time I ran this. I'm pretty sure I did, but I might not have. So if I didn't, then I'm just going to make a fool out of myself, which should be nothing strange there. Okay, we have power on the inverter. I'm going to need the crazy power supply now. Try not to wreck the car keys. Okay, here we go. A crazy power supply. Now the problem with the crazy power supply is that when you turn it on, it has a habit of tripping circuit breakers. So I wouldn't be at all surprised if it managed to do that for us tonight. Here we go. Oh yeah, there we go. That's great. Thank you, crazy power supply. Okay, there is voltage on the DC bus. If I hit the start signal, where's it disappeared to? There's our start signal. We might just be able to spin this thing. Oh, I'm doing it wrong. Oh, damn it. I knew I had to be doing something wrong. Okay, I don't know if this is going to do anything at all. Oh, okay. Yeah, I didn't save the parameters, did I? Oh, actually, well, maybe I did save the parameters because I was running on one phase instead of three. One of these silly wires fell out. There you go. Okay, let's try that. Alright, take two. Oh yeah, there it goes. I'll get you guys down to have a look at this now. Alright. Alright, let's see. So, I don't know if you guys will be able to see this. Let me go back here and see if you can see it. See if you can see. Oh, you can see it. Okay, so here we go. Give it a little throttle. There's our BMW i3 motor, motoring away with Johannes's resolver interface. And speaking of Innova inverters, recognize that thing? That's what's driving it at the minute. So we have pretty much gotten to a point that we can now drive induction and at least some permanent magnet motors. I know Johannes has it working with the Nissan Leaf motor. This is the i3 motor now running as well. So next up will be probably one of the Prius motor generators. So there you go. Let me get you guys back in here. You can regale yourselves on all this junk. Now, so that's it, guys. That's what I've been doing here. Hope you find it at least somewhat boring. I certainly do. So, anything else that I can assist you with this evening, folks, before I fall asleep here? And yeah, apologies for all the networking nonsense earlier. Just one of those things. I hopefully get myself sorted out here. A permanent Ethernet cable out here to the workshop now fairly soon. So there you go. Marvels of modern communication. Well, I think I've succeeded in boring everyone to death then. Yeah, I kind of do tend to have rather weak test leads, don't I? Cheap eBay stuff. But I suppose the advantage of them is that they at least they just burn up when too much current flows through them, rather than damaging something. Yeah, I'm pretty much still breathing, which is always good to be. Let me tell you that. So this is the new lab, guys, and at least we can do some extra crazy stuff here without worrying about killing off the house totally. Got it, you know, this place is fed on a separate 50 amp circuit breaker, so even if I do manage to trip that out, that still doesn't affect the day-to-day operations of things. Sorry for all the yawning. Cheap lead saves money on fuses. Exactly. Yeah, more money to buy cars with. Did I tell you guys as well that I've bought a Prius for 350 bucks? I think I did tell you that. Her name is Black Betty, and I've actually brought her back from the brink of destruction recently. So we'll have some videos on that coming up soon. I know, like, you're probably thinking, what is this, 2008? But I suppose I was late to the Tesla game, so may as well be late to the Prius game too. Better late than never, as they say. So, I'm probably going to wrap it up in a few minutes, guys, if no one else has anything that they want to ask or say or do or anything of that sort, because I am pretty tired. Been a pretty busy now couple of weeks. There's been a lot of things going on, but all good, fortunately, apart from the internet, because that's bad. Peter, I suggest we pick this up in a mail later on. It just sounds like there's a few things we need to work out there. Yeah, well, see you later, guys. Thanks for tuning in. I know there's a lot of time differences that people have to accommodate. I'm trying to, I don't know, maybe if there's a better time that I can do these things, do let me know. I don't really know where the vast majority of people who want to watch this stuff come from. Yeah, I'll be doing a video on the 36 wiring. I'll go through that in painstaking detail so that you guys can play me back at your own peril, I might add. Let me bring me around here so you can see me for a few minutes before. Might as well have a good laugh. Get some sleep, yeah, I know. I need it, don't I? Ah, here I am. There you go, guys. Good evening to you. As you can see, Variac. Got really lucky with this guy. Picked this up for €70. It's practically brand new. Zenith 3 kVA Variac. So very handy for various projects. So yeah. All right. Oh, man, am I tired. So that's it, guys. Gonna have to work on that Prius stuff now to get ourselves a viable charger out of it. I think that can be done. I think it can be done. Well, I'm glad you guys are enjoying the videos. I've recently gotten the heater fully installed in the 36 as well. So I'll have a video on that. That's actually worked out reasonably well, nice and simple. So I will, yeah. All right, Gary, take care. Thanks for tuning in. I'd better go. I'm just falling asleep in the chair here. Okay, folks, I will wrap this one up now. Again, apologies for all the networking madness earlier. Hopefully next time we will have that sorted out more permanently. We will see you in the next scheduled update. Probably see you in another live stream soon. Don't forget to like, share and subscribe. Whatever you do, don't support me on Patreon because I'll just do more of this stuff. And until then, happy Prius inverter hacking. Good night, folks, and take care. I'm going to close up shop and go to bed. All right. Get rid of this thing before they see me butt naked again.